Hello everyone and welcome to another video in my channel. In this video, I have a very interesting problem from Stanford University entrance examination. The problem is d minus 3 in bracket to power 4 is equal to d to power 4. We are required to find the value of d. How are we going to solve this problem? The step-by-step approach will be easy for you to remember if you are faced with a problem like this. Now, what I'm going to do first is to subtract d raised to power 4 from both sides. So that becomes d minus 3 raised to power 4, then minus d raised to power 4 is equal to 0. And the next thing is to rewrite this expression on the left-hand side. So it becomes d minus 3 raised to power 2 all raised to power 2. Since we know that 2 times 2 is 4, then minus d raised to power 2 all raised to power 2 is equal to 0. The next thing is to apply the property in algebra, which is, since we have a raised to power 2 minus b raised to power 2, this problem is now in this form. Difference of 2 squared is what they call it. I will have a minus b, then a plus b. Now, I'm going to rewrite this in this form. So it becomes d minus 3 raised to power 2, then minus d raised to power 2 in the first bracket. In the second one, I will have d minus 3 raised to power 2 plus d raised to power 2. Close the bracket is equal to 0. Since we have two terms multiplying themselves to get 0, it's either the first term is equal to 0 or the second term is equal to 0. So it becomes d minus 3 all raised to power 2 minus d squared is equal to 0. If we expand this, we'll have d squared minus 6d plus 9 minus d squared is equal to 0, where this and this will cancel out. So we are now left with minus 6d plus 9 is equal to 0. This implies that 6d is equal to 9. If we divide both sides by 6, this 6 will cancel this, leaving us with d, and here 3 can cancel to give us 2, and here 3. So we have 3 over 2. So the first solution that we have found is 3 over 2. Let us check if this is a solution to this problem by substituting 3 over 2 where we see d in the original problem. So we have 3 over 2 minus 3 all raised to power 4 is equal to 3 over 2 raised to power 4. Let's convert this to a single fraction. The LCM is 2. 2 divided by 2 is 1 times 3 is 3. Then minus 2 divided by 1 is 2 times 3 is 6. So we have 3 minus 6 over 2 raised to power 4. And here it still remains 3 over 2 all raised to power 4. So it implies that 3 minus 6 is minus 3. Minus 3 over 2 all raised to power 4 is equal to 3 over 2 raised to power 4. Now, minus 3 raised to power 4 is 81. And then 2 raised to power 4 is 16. Here again, we'll have 81 over 16. So this is a solution to the problem. Next is to equate the second part of the bracket to 0. So we have d minus 3 all raised to power 2 plus d squared is equal to 0. If we open this bracket, we'll have d squared minus 6d plus 9, then plus d squared is equal to 0. This time around, these two will add them together because they are the same and the signs are also the same. So we'll have 2d squared minus 6d plus 9 is equal to 0. We have a quadratic equation in D. So let's check if we can factorize this. The discriminant of the quadratic equation is b squared minus 4ac. Our b is minus 6 and a is 2, then c is 9. So let's put them in this expression. That becomes minus 6 all squared minus 4 times 2 times 9. So the discriminant is equal to 36 minus 72, which is minus 36. So this is a complex number because this is going to be under a square root sign. Let's remember that the formula method for a quadratic equation, that is d here, is minus b plus or minus, what we have here is b squared minus 4ac all over 2a. However, b squared minus 4ac, which is the discriminant is minus 36. So d is equal to minus times minus 6 plus or minus the square root of minus 36 all over 2 times 2. This will give us 6 plus or minus 6i all over 4, because here we have minus 36. It is also the same thing as square root of 36 times square root of minus 1, and minus 1, the square root is I, so we have 6i here. Then d is equal to 6 plus 6i over 4, or d is equal to 6 minus 6i over 4. So here d is equal to, if I factorize 2 out, we have 3 plus 3i over 2, or d is equal to 3 minus 3i over 2. Now we have two other sets of solutions. Let us now check if these solutions will satisfy this equation, and we are going to do it here. So the equation is d minus 3 over 4 is equal to d raised to the power 4, and in the first case we have d is equal to 3 plus 3i over 2. Let us see if we are going to get a balanced equation here. So 3 plus 3i over 2 minus 3 all raised to the power 4 is equal to 3 plus 3i over 2 raised to the power 4. Let's convert this to a single fraction. 2 divided by 2 is 1. 3 times 3 is 3. Times 3i will give us 3i minus 6. All raised to the power 4. Why this remains the same. So we can separate this as 3 plus 3i all over 2 raised to the power 4 and raised to the power 4 here. Now, if we rewrite this one, we have minus 3 plus 3i, because plus 3 minus 6 will give us minus 3 all over 2. Here is raised to the power 4 and here is raised to the power 4. Now, if we expand this, we have 3 plus 3i raised to the power 2 all raised to the power 2, and here is 16. Similar thing happens here. Minus 3 plus 3i raised to the power 2 all raised to the power 2 all over 16. So now let us expand this bracket and this bracket. We have minus 3 times minus 3 is 9. Then minus 3 times 3i will give us minus 9i. Again, we'll have another minus 9i, that is minus 18i. Then minus 9 squared all over 16. This and this will cancel out. If we open this bracket again, we'll have 9. 3 times 3i is 9i. 3i times 3 will give us another 9i. We have plus 18i here. Then minus 9 all over 16, all raised to the power 2. This and this again will cancel out. So we have here minus 18i over 16 all raised to the power 2 is equal to 18i all raised to the power 2 over 16. We do not have a balanced equation because when we open this bracket, we are going to get minus. Then this minus will multiply this minus. The minus here, let's remember that I times I is minus 1. And so when we have minus here, it will multiply this one, giving us 18. Giving us a positive value rather. And here will give us a negative value. So the first part of this, which is this, is not a solution. If we try the same thing with this one, we are not going to get a solution. So the solution to this problem is in the very first case, which is d is equal to 3 over 2.